Now let's solve this problem from chapter 16, Hibbeler Dynamics. The problem says that the conveyor belt is moving to the right at 12 feet per second, and at the same instant the cylinder is rolling counterclockwise at omega equals to 6 radian per second, while its center has a velocity of 4 feet per second to the left. Determine the velocities of point A and B on the disk at this instant. Does the cylinder slip on the conveyor? So if the problem statement says that does the cylinder slip on the conveyor, so we do not know the velocity of point A. If the cylinder is rolling without slipping, then the velocity of this point A, which is in contact with the conveyor, will have the same velocity as of conveyor. So now, as we are not sure from the problem statement, we do not know the velocity of A. So we are required to find the velocity of A and B, and then we have to decide whether the cylinder is slipping on the conveyor or it is rolling on the conveyor. But in the problem statement, we are given that the center has a velocity of 4 feet per second to the left. This is very important. So we are given that the velocity of point C is towards the left. So this is the velocity of C towards the left, which is given of magnitude equal to 4 feet per second. So we see is 4 feet per second, and is the velocity of point C, the center is towards the left. So after some time t, this cylinder, the point C should move towards the left, right? So the resultant velocity of point C is towards the left. So if this is my cylinder, so then it must move towards the left, since the velocity of the center is towards the left, since the absolute velocity of the center is towards the left. So this is that point B. So this point C will move towards the left, since the velocity of point C, the center, is towards the left. So this means that this point B is moving towards the left as well, since as we can see that point B has moved a distance towards the left. So this means that the resultant velocity of point B is towards the left as well. So we can say that the velocity of B is towards the left, and the velocity of A is not known, right? So let's assume that the velocity of A is towards the right. So let's say the velocity of A is towards the right, since the conveyor is moving towards the right and this point A is in contact with the conveyor. So we can say that this point A must move towards the right if it is slipping on the conveyor or if it is rolling on the conveyor. But in both the cases, the point in contact should move with the conveyor. So we are not sure about the velocity of point A, but we can say that the velocity of A must be towards the right. So we can say that the velocity of A is towards the right. So this is the velocity of A. And now we know that the velocity of B is towards the left as well. So we can say that the velocity of B is like this. As you guys can see that I have drawn the velocity of A vector small relative to velocity of C, and drawn the velocity of B vector larger, or we can say of bigger length relative to VC and VA. So it's obvious, right? So since we know that the velocity of C is 4 feet per second, and since we are going to solve this problem using the instantaneous center of zero velocity, so in order to have the velocity of C of 4 feet per second, and in order to find the instantaneous center, if the velocity of A is towards the right, so we need to join the tails of these, and we need to join the heads of both of these velocity in order to find the instantaneous center. So if I join the tails of both of these velocities, so we will have a line like this, and I need to join the heads of both of these velocities. So as you guys can see that it's not, if we find the instantaneous center using these two velocities, and let me erase this. So as we can see that this line and this line, they intersect somewhere here. And if this is the instantaneous center for both of these velocities, velocity of C and velocity of A, then for B, for B, its velocity must be towards the left in order to obey this rule of finding the instantaneous center. We cannot draw the velocity of B towards the right, since these two lines must join the tails. This line must meet the tail and this line must meet the head of velocity of B in order to satisfy the definition of instantaneous center of zero velocity. So in order to satisfy that definition of the instantaneous center of zero velocity, the velocity of B must be towards the left, since this line will join the tail of the velocity of B and this line must join the head of the velocity of B. So this means that the velocity of B, the head of the velocity of B must intersect with this line in order to satisfy the definition of instantaneous center of zero velocity. So we can say that the velocity of B must be towards the left and the velocity of B must be in between these two lines, and the velocity of C must be somewhere here. So we need to, since this vector was drawn approximately, so we need to reduce the length of this velocity of C. So the velocity of C must be somewhere here. So now this is the instantaneous center for VA, VC and VB. Let's say that this distance is, let's say, x. The distance of point C from the instantaneous center is, let's say, x. So we can say that this is x. We can say that the position vector of C relative to instantaneous center is having a magnitude of x. So we can say that if we draw a vector from the instantaneous center to point C, that vector will have a magnitude of x. So now we can say that velocity of C is equal to r of C instantaneous center times omega. We can always use this relationship once we find the instantaneous center, r times omega. So now by using this definition, we always think that this point C is revolving about the instantaneous center in a circular path of radius this much, and that radius is equal to x, which is unknown. So we can say that velocity of C is equal to x omega, and from this we can find x VC divided by omega, and VC is given, which is 4 feet, and omega is given as well. The omega is in the counterclockwise direction, and the problem statement says that omega is 6 radian per second. So we can say that 4 divided by 6. So this is basically 2 divided by 3. And since VC is in feet per second, so this x will be in feet. So the distance of point C from the instantaneous center is 2 divided by 3 feet, or we can say 2 divided by 3 is 0.667 feet. So we can say that x is equal to 0.667 feet, or it is 2 divided by 3 feet. Now once we find instantaneous center, we can always use this relationship for all the velocities. So we can say that VA is equal to R of A from instantaneous center multiplied by omega. So now R of A relative to instantaneous center will be a vector drawn from instantaneous center until point A. So we can say that if the radius of this cylinder is 1 feet, if this distance is 1 feet and this x is 2 divided by 3, so we can say that this length is 1 minus x. So we can say that the R of A relative to instantaneous center will have a magnitude equal to 1 minus x. So we can say that this R of A relative to instantaneous center is 1 minus x times omega. Omega is 6. This is VA. We can say that 1 minus x, x is 2 divided by 3 times 6. So we can say that 1 minus 2 divided by 3 into 6, this gives us 2. So the velocity of A is 2 feet per second. This is towards the right, and as we can see that the velocity of A is smaller than the velocity of conveyor, which is the velocity of conveyor is 12 feet per second. So this means that the cylinder is slipping, it is not rolling. For slipping, the velocity of A must be equal to the for pivot rolling, the velocity of A must be equal to the velocity of conveyor. So if it is less than the velocity of conveyor, this means that the cylinder is slipping. That is why the center of the cylinder is moving towards the left. So now we come to the conclusion that the cylinder is slipping. It's not rolling. And now to find the velocity of B, we can always use V equals to R omega. So we can say that VB is equal to R of B instantaneous center times omega. Now R of B relative to instantaneous center is this vector, this position vector, which is directed from instantaneous center to point B. And this vector will have a magnitude of 1 plus x. So this is 1, the radius is 1. So this is 1 plus x will be R of B instantaneous center. So we can say that the velocity of B is equal to 1 plus x into omega. Now 1 plus x is 2 divided by 3 and omega is 6 into 6. So this gives us 10. So VB is equal to 10 feet per second. VB is equal to 10 feet per second. So this VB is equal to 10 feet per second. So this is how we can find the velocity of B and velocity of A using the instantaneous center of zero velocity. So I hope this discussion will help you in your learning. Let me know in the comments if this helps. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Dynamics chapter 16.